So it's on Conan for LabVIEW. What Conan is, I'll explain later, but it's on installing dependencies per project with an open source package manager. Now, I'll first explain what we want, but Jörg already set up the picture a little bit. We faced the same difficulties or things that we wanted to achieve. Then something about handling dependencies, installing them per project, and Jörg also already mentioned the relinking issue, and then the package management itself. So what this is not about, or this is about, and what it's not about, it's a short story of our journey, how to find a solution on those things, an overview of our opinions and findings, and I'll do a short demo of our current process and way of working, and you'll see that it's very easy to use and it handles that per project dependency management very smoothly. I won't talk about how to install Conan or configure it because that will take us too long, or some behind the scenes explanation. But if people get interested, I'll definitely am more than willing to explain it or even collaborate on any further development. And I have no intention to replace any existing package managers that are in the LabVIEW ecosystem. This is just a process that works well for us, and I'm happy to show you. So what did we want? And the journey started a couple of years ago, even before Project Dragon was mentioned. But we want dependencies per project. So everything that belongs to a project needs to be inside the project folder. When you open the project, it's ready to go to work on it. No missing dependencies. Everything that's compiled into the executable in the end needs to be there. We want our dependencies to be version controlled. Now, a little difference on what Jörg said, everything needs to be there, but we also want those packages to be reusable code. So we want to exclude them from the Git repository, but pull them in some way or the other. And there needs to be version control on the dependencies. If I update the package, I want to say this project uses package A version 2. Well, that needs to be a small change in Git instead of overriding the entire folder of that package in your project. We wanted an easy way to share and deploy it between colleagues, but also with our continuous integration system. It would be nice to have the same workflow for all our developers, not only the LabVIEW islands in the company. Preferably open source and preferably free, but I mentioned it in all my presentations. Now, having dependencies per project, do we really want to make everything a part of the project? As I mentioned, no, the reuse code is not a real part of the project, but you use it inside your project. So we exclude it from the Git repository, but we include an overview. It's like including a fibc file in your Git repo, but not the actual package itself. And also different projects can have different requirements. So if you install your packages in your user lib, you get a conflict there. And that's why we want to install in the project itself, not in a common folder. And then there is this relinking issue that Jörg also spoke about. When you put all the dependencies inside we call it a support folder, the relative path might change, because when you're working on package A, it has a relative path to its dependency C. But when you put it inside the project, they might not be on the same location relative to each other on disk anymore. So we wanted to avoid the relinking. And just to show you a little bit, if you have A with a support folder that contains C, the code of package C, we have B that also has a dependency to C, and C is no dependency at all. Now, when we create a project, the support folder will contain A, B, and C, but B and C need to be relinked. A and B need to be relinked to C, because C isn't in their support folder anymore. And to avoid that, we started using packed project libraries. So we built A, B, and C, excluding their packed dependent packed libraries. And then when we all put them next to each other in a support folder of a project that is auto-populating, when we open the project, they're all loaded into memory, they'll find each other, and goes smoothly. The support folder is ignored by Git, and it is populated by the package management. This is just to tell a bit about why we use those packed project libraries and avoid the relinking by doing so. It's not on package management itself. Now, we were thinking about how can we then put those packed libraries in that support folder. We can copy them. That's what Jörg is doing. But then there's no real version control or something. We can use a zip and have a manifest file in there. I've been thinking about that, but then I was thinking like, hey, I'm reinventing VI Package Manager a little bit, so that didn't seem useful. Using Git submodules, we've tried one project with Git submodules, but it was difficult for all developers to update get the submodules updated and manage multiple repos in one project. I have seen a couple of presentations on this topic as well, and one was called Dependency Redemption. It was on the UK TAC and on the GLA Summit last year. And they showed a tool like this, or the guys from Compose System, I believe. And they also relink packages and do some stuff with Git. Another one is the Git submodules presentation of Greg Payne on GDevCon. A lot of inspiration, but still it wasn't completely what we were looking for. There are package managers out there. The PIPM and IPM, they don't work per project, not until there's Project Dragon. GPM does work per project, but it also didn't really fit what we intended. And then we have a bi-weekly software process meeting at our company, which includes developers from all kinds of languages. And our C developer said to me, hey, what you're trying to do looks like a very good job for Conan. And my reaction was, well, what's Conan? And Conan is an open source package manager developed for C, C++, but it can also handle binaries. It's very easy to install because it's a Python package. You just run pip install Conan and it's installed. You still need some configuration for profiles, but that was very easy to figure out. It's very well documented, and it's a decentralized package manager. It has a local cache, but you can also upload packages to your own server, which makes it very easy to distribute them. And another advantage was it was already used within Intersoft Electronics. Some of my colleagues have knowledge about Conan, about how to package stuff, how to upload stuff. So I thought, let's give it a go. Now, the first
sorry
command,
to interrupt, Stefan, but
yes.
Mike had a question.
Yes.
For Conan. Mike?
Yes, I have. Yes, I have had a question. You just mentioned at the very beginning that the GPM was having a support for projects, but it was not enough for you. Could you point what was the missing thing, the thing that you were disappointed with it, that you are still looking for better solutions?
Oh, which one? You said
the last package manager.
Yeah, the GPM. Well,
yes.
Because it's also a specific package format, and well, I thought it was a bit hard to start using. Also, deploying packages and having them somewhere on a server and things like that, I couldn't find straight away there. So mainly that part. So about Conan, I hope it answers your question, Mike.
Yes, thank you very much.
Okay. Well, if you install Conan, the first command to run should be, I'm going to start a command line here. Conan Frogarian is their mascot. Conan is open source, but it's maintained by a company called JFrog. And when you run Conan Frogarian, you get this warrior. So now we know it's running. How to use it? Each repo should have a Conan file.py, or at least we are using it with the .py files. This contains all of the requirements, so all the dependencies actually, just a list of dependencies. And in our case, I'll show you an definition of an extension class in Python. Can also contain scripts that override methods in the Conan base class. We run it from the command line, but it would be nice to have a GUI in the future. And each command that we run will execute several methods of the Conan class. Now, the Conan py file is a very small file. It has a class, LabVIEW class. It requires this one, requires library C, version 0. Take the latest version there. Then it requires our LabVIEW Conan extension, which is a package that we made, which contains a LabVIEW Conan extension class, and that does all the heavy lifting for us. So all the LabVIEW packages will be packaged and handled in the same way. Now, to use it, I run a command called Conan create dot in the directory where in the folder where I need to create a package. I can run a Conan install dot which will install all the requirements for the current repository, or I can upload all my packages to the remote. Basically, these are the only three commands that I need. The create, what will it do? It will determine a version name, which is actually the name of the LabVIEW project, the name of the file. It will determine a version, and I will show you in the next slide how we do that. It will do some stuff that's always there in Conan, but that we didn't override. And then in the source step, it will do a git clone. Oh yeah, here in the Conan file.py, there's also a git URL. So to the repo, and then it will clone it to its cache folder /source. So on disk, there's a .conan folder in your user folder somewhere. For each package, it will determine a GUID, and that will have a subfolder cache, subfolder source. So then it will clone your repo there. It will clone it and check out the commit that you're also currently working on. But this is very important because if you want to change something, you have to push it, because creating a package will take a clone from the server. It will import, so install all the requirements, all the dependencies inside that source, actually inside the source/support folder. It will build, which will actually run all the build scripts that are in the project file using gcli. It will package, so it will copy everything from that build to the cache package library. And I'll show you later what it actually does. About this version number, what we do is...
Just a second, Stefan. Theo had a question.
Hi, Stefan. What about if the dependency of version of C, and dependency in A is to version 1 and a dependency in B is version 2?
Well, then,
how would it solve the dependency differences then?
Conan will complain about it, but that's also a problem that you currently have with your current package manager. So it will complain. It will raise an error.
Okay.
Because your project needs to use one version of C.
Okay, thank you.
And also, Jesper mentioned in the comments for you, Stefan, that there's a Python package called GUI that could handle converting CLI to GUI tools. So that might be worth a check.
Yeah, but what we are looking for is actually a GUI tool to manage these requirements. Something that's similar to VIPM. You have a list of what packages are out there and which are installed in this Python file and can update something or not. So now if we have to update the requirements, we have to manipulate a text file, a Python file. So it would be nicer to do that in a more user-friendly way. We determine our version numbers by taking the latest tag with respect to the current commit from Git, and that tag should be x.y.c. We use this Git command. We also calculate the total number of commands until the current, and that gives us a build number. So our version number will be, if it's in a master branch, x.y.c.build number. In any other, usually a develop branch, it will be z+1, because then we're developing for the next fix, probably. This way, the build number is always unique, and it always gives us automatically build number. One thing that we do, if we develop builds, the PPLs will have debug enabled. Otherwise, in master builds, it won't be. And it's done automatically by the GCLI VIs that we created. The Conan install will install the required packages, so it will actually copy everything from package lib to support. So if you say C as a requirement, it will copy from the C cache package libs to the current support folder. If you have B as a requirement and B has C as a requirement, it will automatically also include C. So you don't have to specify C if it's a sub-requirement. And then upload. Uploads everything or a package from our local cache to the remote server. And Conan works very well with Artifactory, which is a repository for artifacts, for binaries. And it's also from JFrog. And that was also already used within our company. But I also discovered that it integrates very well with the GitLab package registry. So if you're using GitLab, you can also use this. If the install doesn't find a package in your local cache, it will try to get it from the remote. If it's not in the remote, but for any reason your Conan file.py is, it will even build it because it knows the Git URL and it knows what to do. Now let's do a small demo of our process. I'll start with an empty folder. I'll do a git bash here. It's taking a while. So what I'm going to do is I'm going to check out this library C first, and I'm going to package it. So git clone, and I still have it in my copy. So there it is, library C. I'll show it in git fork. One trick that I did, I used X mouse button control, and when I click the middle button of the mouse, it opens the repo in git fork. I'm gonna track my develop branch. So now we're here in develop. And what I can do here is open a command line in this folder, and I'll do Conan create. First, I'll show you Conan search. Conan as one package right now. That's our Conan extension. That's what we need to do to override all the scripting for LabVIEW. And now Conan create dot, and it will start creating the package. It will determine the name, determine the version. So it says this is the version 0011 because we have a 00. It's in develop, so it's this +1, and it shouldn't be 1. No, it's 10. Sorry, 10. 0, 1, 10. 4, 5, 6, 8, 9. It's the 10th commit. It opens LabVIEW, creates the PPL, and puts it in a package. So now Conan search knows package C. Well, I'll show you another short tutorial.
Stefan?
Yes?
Just a quick question from Michael. Is it possible to use Conan to download artifacts from GitHub releases? Have you any experience with that?
I don't have experience with that.
Okay.
I don't know.
So that
I don't know how it works. Because on Conan, a remote list, you have to list some remotes. So you can configure a remote server, and then you tell them you should upload to there, or you can all the configured remotes. He will look if it contains that artifact. But I'm not sure on GitHub. I've seen pages on GitLab integration.
So GitLab releases are not the same as the GitLab package repository. So I'm not sure if GitHub releases would work.
Yeah, what I've seen is GitLab package registry, because that's something that's made for packages, artifacts, binaries, and a Git repository. Normal Git repository is not made to handle binaries very well. So, yeah.
Okay.
So now we have created package C, where it's now suppose we're going to work on B, which has C as a dependency. And for some reason, my Git bash is very slow, but it will pop up. There it is. What we have to do is clone library B here. Now, when we open this, I'll open it in Git fork first. Try to develop. Now, I like Git fork a lot because you can enter custom commands. So I can open this in LabVIEW, which will open it in the correct LabVIEW version. And it's missing the support. So when I open this, it's not finding C, because C was not in the repository. Now, I can do a Conan install dot in this folder, or I've added it to the Git fork menu, Conan install. It says I copied one file. When we look on disk, in the support folder, it contains the packed library. And when I open it in LabVIEW, it's also there. And now I can do B. B contains, well, and this is a developed version, so we can even debug it because the block diagram is still there. Now, 1 minute. Let's do the same for A. And I'll already do the project as well. Yeah, it was a quick proof of concept, so I didn't bother choosing useful names. And then you asked to do a demo. So for A, I'll open Git fork again. Trying to develop version. Install the dependencies. I'll create A. So it's running here. So the actually building it is a VI for gCLI 2. It passes some additional parameters like a version and debugging enabled or not. So this one is done. We still have to create B as well. actually the library contains one VI that's called get version, and it gets the version of the packed library, so I can check that it's using the correct versions. A and B do have a dependency to C because they say we use this version of C. I'll show you later. But it also packaged one.
Hey, Stefan, you're muted.
Oh, so don't know how that happened, but yeah, I've opened the project file and installed the dependencies. They're next to each other on disk. And when I open the project in LabVIEW, it can find them, it loaded them. So everything's
Enrique
there.
had a quick question about Git fork. How did you add the custom open-in command?
If you go to the preferences in Git fork, it has custom commands. The open in LabVIEW is on the repository. You open in LabVIEW, you start an action, and it uses the batch file. I'll show you. In launch LabVIEW, it's actually, it uses the LabVIEW shell launcher, which is a tool, and then you have to also, it looks in the current directory for the project file and it passes that to the shell launcher. So that's a batch file, and then in Git fork, you tell it to run this in the current folder. That's the advantage of Git fork. It runs the command in the current folder. So we can run VI analyzer, JCAG tester, build it, get version numbers, stuff like that. So that speeds up our development process a lot. And also, well, there was a quick demo of what we do with Conan. One more thing is that I'll do command line. Conan search will, now there will be all these packages, and I have to take a look. It's in my presentation. If I run this command, I'm not sure it will work. Oops. No, because the remote needs to be test Conan dev local. Well, first of all, okay, this is what artifactory looks like. Currently, this is just a process that I'm running locally, but we have a version that runs on the company's servers. So now it contains this LabVIEW extension, because that was already there. And this is a repository that you can set up. Now, when I do this, it will sure. It's not doing anything. So Conan upload WUELUG. So it will upload them. And now when I refresh this page, they're all there. So now they're all on the server as well. So these are the artifacts, the package. And somewhere deep down there, there's a lib file which contains which contains the pack library. So that's about the server part. Now to wrap it up, some pros and cons. We have our project dependencies under source code control. We have the same workflow for all our developers because more than only the LabVIEW developers are used to work with Conan. It was free and open source with very good documentation and turned out quite easy to use. There's no nice UI to manage our dependencies yet. It's not the default LabVIEW way of working. There's no IDE integration with LabVIEW, and we only have our own reuse code in there, so not the community stuff or some tools that we still keep using. So that's about it. If there are any more questions, feel free to ask, or if you have more advanced questions, contact me later. Yeah.
Actually, there was a question from Michael in the chat. Is the building process necessary when using this solution, or is it just your convention? I mean, if I have a nice release process and all my artifacts are stored in Artifactory, do I still need to rebuild each time I download dependencies for this project?
Sorry, not sure what he means.
Maybe I will clarify what I meant. So if I understand correctly, how you have configured it, you use Conan to, when you download dependency for your project, you download source files from a Git repository, store it somewhere in cache, and rebuild it?
No, it's not done that way. Once it's built, it's in the cache, and it will just install whatever was built back then. But if it's not, if the cache doesn't contain the build, it can still build it, but it's not building it every time.
Okay, so it's like in this Conan configuration file, you specify Git repository.
Yeah, but
unless you don't have it already built in your cache.
I can show. Yeah. In my Conan file for the project, there is no Git URL because I'm not building the project file with Conan because it's an executable. But also, once I created a package, it will be in the cache, and everybody else that's consuming it is just copying the pack library from the cache. The pack library won't be built again.
But this cache is your local cache, right?
It's your local cache, but if it's not in the local cache, it will look on the server, because when I build something, it's not in the local cache of my colleague. So when he needs that package, the first time it will be downloaded from the server, and then it will be in his cache.
Okay. So normally after it's built, you store it in Artifactory, and like compiled artifacts are downloaded from Artifactory, or if it's not compiled, you download it from repository? Because I'm confused, to be honest, between when do you download it from the repository and
actually
when do you use Artifactory?
Yeah, in LabVIEW, we actually only build it just before uploading it, and then it's there. It's a very rare situation that your Python file only this file would be in the repository on the server and not the package itself. You can do it. There are commands to do so. You can export this one. And then it has a recipe on the server, and it still can build it once you need it. But we're not doing that. We just create a package, upload it to the server, and somebody else downloads it to its cache and uses it. That's just copying files, and that was what my colleague told me. That's what Conan's good about. We wanted to put some files in place, and that's what a package manager needs to do.
Okay, now it's clear. Thanks.
So we use this to move files around and to run some steps in a controlled way, because we had a lot of things already there. Our Git fork.
Stefan, I fear we have to come to an end
no problem.
because we're already running over.
No problem. One thing. The question, but if anybody knows the Advent of Code, I ran it last year, and I'm planning to do a score board for LabVIEW users. So I'll post something in the WUELUG forum, and then people can ask me to get the code for to access that scoreboard if they're interested in taking part of the Advent of Code.
Very cool.
Okay.
Awesome. Stefan, thank you so much. And thank you also for offering to be there to answer questions later on, because I know I have some, and the other people will as well, I guess. I always envy those of you who are in a kind of a closed environment where it's easier to come up with customized solutions. For us as a company working with many customers, these things are sometimes more complicated or like harder to suggest. But I can totally see all the advantages that you guys have now compared to what we have in our process. And it's very intriguing. So it's a very nice, very streamlined solution, I guess. There's some LabVIEW envy here right now.
It feels streamlined, but it was a very short time to show everything. But if people are more interested, we can talk about it later on another event.
Awesome. Okay. Again, thank you for sharing. I know it was on very short notice.
No problem.
As I mentioned in the beginning, some people canceled, and Stefan was there for us. So big kudos to you. Thank you.